All right, so our last section is complex fractions. So if we look up there, it's like a fraction within a fraction. And there's addition in the top and bottom, okay? So it seems like a lot, but we can just kind of get through it piece by piece and use what we've known, and it's not too bad. So the first thing you got to remember is when you write a fraction top bottom like this, okay, there is really an imaginary set of parentheses on top and an imaginary set of parentheses on the bottom. So that's telling us that we would have to do that addition or subtraction in the numerator or denominator first, and then we would have to divide after that. So that's our first step. We need to add, in this case, subtract the numerators and add our denominators. So we're adding or subtracting, which means we need to have a common denominator. We need common denominators anytime we add or subtract. So tell your neighbor, your person next to you, what's the common denominator for the top? What's the common denominator for the bottom? So if you look just at the numerator, what's your common denominator? If you look just at the denominator, what's the common denominator for those? All right, what do we think? Logan, what do you think the top one is? Remember, you can't leave any factors out. So what's the first factor? What's the second factor? So what do you think our common denominator is going to be? Yeah. What's our common denominator for the bottom? 4x. All right. With that being said, what is our first fraction missing in the numerator? 2. So multiplying top and bottom by 2 over 2. In our second fraction in the numerator, what's that fraction missing? An x. So I'm multiplying top and bottom by x over x. In the denominator, again, our common denominator is 4x. So our first fraction has an x in the denominator. So what's missing? 4. So I have to multiply top and bottom by 4 over 4. In our second fraction, it has the 4, but it's missing the x. So we have to multiply second fraction by x over x. Okay, so that would give us, on the top, our common denominator is 2x. And so 2 times 1 is 2, minus 3 times x is 3x. In our denominator, our common denominator is 4x. 4 times 1 is 4, plus 3 times x is 3x. Okay, so we did the addition already. That was inside those imaginary parentheses. Now we're going to have to divide. So we're dividing two fractions, which means we're going to have to do what little strategy? Keep, change, flip. So I'm going to keep the top fraction the way it is, 2 minus 3x over 2x. Changing that division to multiplication, and then I have to flip my second fraction. So it would be 4x over 4 plus 3x. So it's now a multiplication problem. So we want to factor anything we can factor. In this case, there's no GCF I can factor. So I am just going to leave it as 2 minus 3x. I mean, I could pull out a GCF of -1. So why don't we do that? We'll pull out a GCF of -1 here. So negative parenthesis 3x minus 2. 2x is really 2 times x. 4x is 4 times x. And the bottom, I can't pull out a GCF out, but I'm just going to write it so the x comes in front. 3x plus 4. All right, now that we have that, I can look to cancel any like factors. So there are a few things that I can cancel. What can I cancel out here? Not a lot, but I can reduce a little bit. So I can get rid of the x's totally, right? X over x. And what can I do with the 4 and the 2? Reduce that. So 2 goes into 4 2 times, 2 goes into 2 1 time. And so now as I multiply straight across, I'd have 2 times negative quantity of 3x minus 2. So that would just give me negative 2. And then the quantity of 3x minus 2. I don't have to multiply that through. If you really want to, you can. You don't have to. And then on the bottom, I would have 3x plus 4. Now we would have to do our restriction here. So in the denominator currently is 3x plus 4. If I set 3x plus 4 equal to 0, I get minus 4. 3x equals negative 4. And then divide by 3. So x cannot equal negative 4/3. Also, there was an x in our denominator, so I also can't be 0. And remember, since we flipped this second fraction, we also have to look at the numerator of the second, but there's an x there, which we already did that. So we only have 2 restrictions there. So again, was this a lot? Yeah, it was, but if we kind of broke it down, think of it as an addition problem first. Once we did the additions, we did keep, change, flip, and followed that. So it's almost just kind of like 2 problems in one. Do you want to do one more example, or do you want to try one? Should we do one more? All right, let's do one more, and then you can try one on your own. So there's the one we'll try on our own here. So again, we need a common denominator along our top and common denominator on our bottom. Because when you write a fraction like that, there's really imaginary set of parentheses around the top and imaginary set of parentheses around the bottom. So our common denominator for the numerator is what? That'd be a common factor. We need a common denominator, so like a common multiple. Ro, what do you think? 9. 9's our common denominator. And our common denominator for the new denominator is 3. So we don't have to do anything to our bottom right now. But we do have to multiply the first fraction in our numerator by 3, because we need that to become a 9. 3 times 3 is 9. So that would give us 6. First of all, our common denominator on the bottom is 9. So 3 times 2 is 6. And then plus x minus 7 over our common denominator on the bottom is 3. And we'd have x squared minus 1 along our top. So we already just did our addition problems. Now we're doing our keep, change, flip. So I can combine my like terms. X, 6 minus 7 is negative 1 over 9. Changing that division to multiplication and then flipping the second fraction. So I would get 3 over x squared minus 1. So it is now a multiplication problem. And what do I have to do before I can actually multiply straight across? What's the one thing that I can do here? Good. I can reduce the 9 into 3. I can. So 3 goes into 3 one time. 3 goes into 9 3 times. There's one other big thing that I can do here, Jackson. But this is x squared minus 1. So you're thinking of it as x minus 1 quantity squared like that.
Yeah, can you take the 1 on the bottom right and then the 1 on the top left?
No, I can't cancel out the 1s. Because remember, that's separated by a subtraction. What special feature is x squared minus 1? Perfect square. So I have to factor this. So I'm going to do x plus 1, x minus 1. Now that that's factored, now I can cancel out the x minus 1 with the x minus 1. And so this top becomes 1. So 1 times 1 is 1. On the bottom, I have 3 times x plus 1. And then my restriction, x cannot be negative 1 or positive 1. All right, so take a moment and try doing this one. All right, so what's our common denominator for the top? Logan, what'd you get for the 81x squared? Common denominator for the bottom? 9x. All right, so I have to multiply top and bottom of my first fraction by, what's missing? It has 81, it's missing, x squared. Top and bottom of the second fraction by 81. On the bottom, first fraction has a 9, so it's missing the x. Second fraction has the x, but it's missing the 9. So we would end up with x squared, so 81x squared on the bottom, that's our common denominator. And then 1 times x squared is x squared, minus 1 times 81 is 81. So I have x squared minus 81 on the numerator, 81x squared on the denominator. On the denominator of that complex fraction, I'd have 9x. And then I have 1 times x is x, plus 9. 1 times 9 is 9. All right, now we're doing our keep, change, flip. x squared minus 81 over 81x squared times, flip this, 9x over x plus 9. What do I have to do to that numerator of the first fraction? You got to factor it. It's difference of squares. So this would become x plus 9, x minus 9. I can also think about 81x squared as 81 times x squared and 9 times x there. And I can't factor x plus 9, so I'm going to put that in parentheses. So what cancels out right away? You can see. Okay, so the 9 with the 81. 9 goes into 9 one time. 9 goes into 81 9 times. Then I have x to the first over x to the second. So this x totally goes away, and this becomes then x to the first. And what's the other thing that can cancel out then? The x plus 9 with the x plus 9. So what are we left with on the top then? X minus 9 on top. And we're left with, on the bottom, 9 times x to the first. And then our restriction would be x cannot equal 0, because 0 squared is 0, and then negative 9. All right, we'll do one more here. So this is still a complex fraction. Just so we have just a number in the bottom now. So what I would do is I would think about this as 7 over 1. And we still need a common denominator along our top. So this first denominator is x plus 7. The second denominator is x. So what's our common denominator going to be? Elliot, what do you think our common denominator for the top is going to be? Perfect. So that means the first fraction's missing the x. So I multiply first fraction by x over x. Second fraction's missing the x plus 7. And I don't have to worry about doing anything on the denominator right now. So I'm going to end up getting here on our common denominator on the bottom, x times x plus 7. My numerator, 1 times x is x, minus, so you got to be careful here. Anytime we use minuses, we have to make sure we use brackets or parentheses. And then 1 times x plus 7 is just going to be x plus 7. But again, I'm doing a negative 1 that's really in front of that. On the bottom, I'd have 7 over 1. So before I can go any further, I do need to distribute that negative 1 through. That would give me x minus x plus 7. Well, x minus x is 0, so I just have 7 in my numerator now. So I'd end up with 7 in the numerator, x times x plus 7 in the denominator, and then I'm going to change this division to multiplication, and I have to flip this second fraction. 1 over 7 now. And I made a mistake here because this needs to be minus 7. I have to distribute that negative 7 through. So that's minus 7. That would be minus 7. That's why you use the parentheses. You got to distribute the negative sign. All right, so what's the last thing we can do then? What can we cancel out? Right. And so we're going to be left with a negative 1 on the top and just a 1 on the bottom. So as I multiply straight across then, negative 1 times 1 is negative 1. And then I'd be left with x times x plus 7. And x cannot equal 0 or negative 7. So just be aware, when you see a problem where it's just a number on the bottom, that's fine. Just put a 1 underneath there. Still keep change flip. All right, so tomorrow you'll work on a couple more problems like this. But for tonight, I want you to work on your study guide, page 2.